morning, everyone. Today I will be talking about the natural logarithmic function and I will be focusing on the integration. So, the following are the objectives for today's lesson. The first one is we will be able to use the log rule for integration for us to integrate a rational function, and the other one is we will integrate trigonometric function. So we have different rules to follow, or we have the log rule for integration that we will able to use for us to find the integration of the following logarithmic function. The log rule for integration states that when we integrate the reciprocal of the variable x, the result is the natural logarithm of the absolute value of x plus the constant c. So this rule is derived from the differentiation rule for the natural logarithmic function, which states that the derivative of the natural logarithmic x, absolute value of x, with respect to x is 1 over x. By applying the fundamental theorem of calculus in reverse, we obtain the rule for integration. So the first theorem 5.5 log rule for integration. Okay, let u be a differentiable function of x. So the integral of the first one, the integral of the reciprocal of x with respect to x is equal to the natural logarithm of the absolute value of x plus the constant c. While the other one, the number 2, it is the integral of the reciprocal of u with respect to u is equal to the natural logarithm of the absolute value of u plus the constant c. In this expression, the integral symbol, it represents the process of integration, which involves finding the antiderivative of a given function. The fraction in the integrand represents the function we are integrating, and the variable next to the integration symbol indicates the variable for integration. So in this case, we have the x or the u. The result of the integration is given on the right side of the equation, where the ln, or the natural log, represents the natural logarithm function in the absolute value of x, or the absolute value of u, it represents the absolute value of x or u, and the c represents the constant of integration. So by using these expressions, you can perform integration on functions that follow the given patterns, and we can calculate the antiderivative. The second formula is an alternative form of the logarithmic rule for integration. So this rule is derived from the fact that the derivative of the natural log of u with respect to x is equal to the derivative of u over u. So it is important to note that the absolute value of u is used in the logarithmic rule to account for negative values of u. So this will ensure that the logarithm is defined for all real values of u except that u is equal to 0. So to read this expression here below, the integral symbol, which represents the process of integration, this involves finding the antiderivative of a given function. So the fraction here, which is the derivative of u over u, it represents the function that we are integrating. Here, the derivative of u represents the derivative of a function u with respect to x, and u represents the function itself, while the dx represents the differential of the variable of integration, which in this case is the x. So, and also the result for the integration is given on the right side of the equation. Here we have the natural log of the absolute value of u. It represents the natural logarithm of the absolute value of u, and the c represents the constant of integration. So the integral of if we're going to read this as a whole, so the integral of the derivative of u with respect to x divided by u with respect to x integrated with respect to x is equal to the natural logarithm of the absolute value of u plus a constant c. So this formula allows us to find the antiderivative of a function in the form of derivative of u over u, and expresses the solution as the natural logarithm of the absolute value of u plus the constancy of integration. So we have the following example using the log rule for integration. So in this given example, the integral of 2 over x is found by applying the constant multiple rule, which states that the integral of a constant multiplied by a function is equal to the constant multiplied by the integral of that function. Next, the integral of 1 over x is found using the log rule for integration. The log rule for integration states that the integral of 1 over x is equal to the natural log of the absolute value of x plus a constant of integration. So this rule is derived from the property of logarithms, which states that the natural log of absolute value of x can be written as ln x if x is positive and ln negative x if x is also negative. So in the final step, the absolute value notation is unnecessary because x squared cannot be negative. Since x squared represents square of a value, it is always positive or zero. Hence, the absolute value notation can be ignored in the final form of the antiderivative, and it can be simplified to ln x squared. Okay. Integrals to which the log rule can be applied often appear in disguised form. For instance, when a rational function has a numerator of degree greater than or equal to that of the denominator, division may reveal a form to which you can apply the. Okay, so we have another example here using the long division before integrating. So here we will need to find the indefinite integral of the following. And the indefinite integral of the fraction numerator x squared plus x plus 1 and also the denominator x squared plus 1 with respect to x. Next, when we simplify and separate the integral, we can have the integral is split into two parts. The first part is the integral of 1 with respect to x. The second part is the integral of x over x squared plus 1 with respect to x. For each part individually, the integral of 1 with respect to x is x plus a constant of integration. And for the second part, after applying the substitution and simplifying, the integral of x over x squared plus 1 with respect to x is equal to the 1 half ln the absolute value of x squared plus 1 plus a constant of integration. Okay, after that, we can rewrite as two integrals where we can have here the integral of dx plus 1 half and then the integral of 2x plus x squared plus 1 dx. And we can now integrate the following x plus 1 half the natural log of x squared plus 1 plus the constant c. So check this result by differentiating to obtain the original function. So here is the following log rule for integration. So the following are the guidelines that we can use for integration. So these are the four guidelines for integration. The first one, we need to learn the basic list of integration formulas. This will include those given in the section. You now have 12 formulas, the power rule, the log rule, and the 10 trigonometric rules. So later I will show you the different trigonometric rules. So we also have here find an integration formula that resembles all or part of the integrand, and by trial and error find a choice of u that will make the integrand conform to the formula. When you cannot find a u substitution that works, try altering the integrand. You might try a trigonometric identity, multiplication and division by the same quantity, addition and subtraction of the same quantity, or the long division. Be creative. If you have access to computer software that will find antiderivatives symbolically, you can also use it. So here are the different integrals of trigonometric functions. So the integral of the 6 basic trigonometric functions, we have the summarized following integrals of the basic trigonometric function, wherein we have here the integral sine u, derivative of u is equal to the negative cos u plus c. Same with the other trigonometric function. So you can study this one in advance, or you can apply this one whenever you solve integrals for trigonometric functions. That's all, and thank you for listening. Have a good day.